Welcome to the discussion and thank you for always joining us. We are looking at KCSE 2003 paper 2 number 17, a question on matrices, and the question we have reads: given simultaneous equations 5x plus y is equal to 19 and minus x plus 3y is equal to 9, write the equations in matrix form, hence solve simultaneous equations. What we are going to do, I'm going to start by first bringing the two equations down. That is 5x plus y is equal to 19 and minus x plus 3y being equal to 9. Then write them in matrix form by separating the coefficients of x and y. We are going to have 5, negative 1, then 1, 3, x and y, and then we are going to equate this to 19 and 9 respectively. That way we have written the two equations in matrix form. Then next we are supposed to use matrix method to solve the simultaneous equations. The first thing we are going to do, we are going to start by first getting the determinant of the matrix, and we are going to get the determinant by getting the product of the elements in the main diagonal, that is 3 times 5, minus the product of the elements in the other diagonal, which is negative 1 times 1. This is going to give us 15 minus 1, and this one is going to give us positive 16. Once we have gotten the determinant, we get the inverse of the matrix, and the inverse is obtained by getting the reciprocal of the determinant. Then we interchange the elements in the main diagonal such that where we have 5, we are going to have 3. And then where we have 3, we have 5. Then we interchange the signs of the elements in the other diagonal. Instead of negative 1, we are going to have positive 1. And instead of positive 1, we are going to have negative 1. And that forms our inverse. Once we have the inverse, we take the inverse and multiply on the two sides of the simultaneous equations expressed in matrix form. That is, we are going to have 1 over 16 into 3, 1, negative 1, 5. This is our inverse. Then multiply this with 5, negative 1, 1, 3, which is the matrix. Again, we multiply this by xy, and this one is going to be equal to, we have the inverse, which is 1 over 16 into 3, 1, negative 1, 5 times 19 and 9. We do not multiply this other side because it will give us the identity matrix, which is 1, 0, 0, 1. This one is going to be multiplied by xy. So our multiplication is going to be on the right hand side, where we retain 1 over 16 outside. Then we multiply the 2, that is 3 times 19, you get 57, plus negative 1 times 9, you get minus 9. Then 1 times 1, you get 1 times 19, you get 19. Then plus 5 times 9, you get 45. Remember, we multiply row and column. In this case, we are going to have this being equal to 1 over 16 times 57 plus minus 9 will give us 48, and 19 plus 45, you get 64. If you take 1 over 16 times 48, this one is going to be equal to 3, and 1 over 16 times 64, you get 4. That means xy is going to be equal to 3, 4, where x is going to be equal to 3, and y is going to be equal to 4 as the answer to this particular question. That gives us the answer to part A, then takes us to part B, that reads, part B of the question reads, find the distance of the point of intersection of a line x, that is 5x plus y is equal to 19, and minus x plus 3y is equal to 9. So what we are going to do from, of course, a point 11, negative 2, the point of intersection of the two lines is 3, 4, and we are supposed to find the distance of the point of intersection from a point 11, negative 2. So if we can try to have a sketch of this diagram, from a point 3, which is the x coordinate, to a point negative 2, we are going to have a distance of say, from 3 to 11, that is the x coordinate, we have moved a distance of 11 minus 3, which is going to be equal to 8. And from 4 all the way to negative 2, we have moved a distance of 6 units. That is, we have 4 minus 2, giving us a total of 6 units. That means the distance we are looking for is the distance equivalent to the hypotenuse, and we are going to get this by simply taking the difference we are going to get this distance by getting the sum of the squares of the coordinates along the x-axis added by the difference of the coordinates of the squares of the distances along the y-axis. That is, we are going to have the distance calculated by taking 11 minus 3, then you square, plus we are going to have 4, or simply negative 2 minus 4 squared, which is going to give us 8 squared plus 6 squared, that is negative 6 squared, and this one is going to be equal to the square root of 8 squared is 64 plus 6 squared is 36, which is going to give us the square root of 100, and this one is going to give us 10 units as the distance from a point 3, 4 to, that is the intersection point of the two lines, and 11, negative 2. Thank you for watching and welcome to our discussions. And in case you're watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we produce a video like this, you will automatically be given a notification. Thank you and welcome.